Hello, algebra students, Mr. Lawrence here, and today we're going to be learning about number systems. You've heard teachers use words like whole numbers, rational numbers, but you probably don't know the difference between most of them. Well, we're going to learn all about them. I'll give you some definitions, and there's actually 6 different families of number systems that we're going to need to know. I'll show you a cool little picture to help you learn it, and then you might want to make some flashcards or study from them, however you can keep them straight. All right, so the first thing I'm going to mention are the real numbers, and they have this symbol, an R with an extra bar. It's real simple. You just draw an R, and then you put an extra bar in it, like that. Okay, the real numbers. The real numbers are called real numbers because in math there is actually something called imaginary numbers. Now we're not going to use imaginary numbers a whole lot in Algebra 1. I'll mention them. There might be a situation where we talk about it. I'll just say that an imaginary number is not a number you made up when you were a little kid. It is not like 11, okay? It's not a bazillion. An imaginary number is a number system that comes from the number systems that's used to deal with the square roots of negative numbers. Okay, I know that most of you know the square root of 4 is equal to plus or minus 2, but the square root of negative 4 doesn't exist because there is no number times itself that equals negative 4. So anyway, hold on one second here. Let me see if I can close this. There we go. All right, so we won't be dealing with imaginary numbers in this class very much, and you'll hear me mention them from time to time. But this is why we're called the real numbers. The real numbers are numbers that have existed. Many of them have existed for a long time. I guess they've always existed, but they've been used for a long time. Now, the first subset of the real numbers are the natural numbers. And you might call those the counting numbers. Some people call them the counting numbers. The natural numbers, they start with 1, and they go on 2, 3, and they continue on forever, okay, from 1 up. They do not include fractions, no fractions, and no decimals, unless the decimal is like 1.0, all right? So no fractions, no decimals. They're all the natural numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, on forever and ever and ever. 1,152 is a natural number because you can count to it. All right, you'd eventually get there. All right, the next subset are the whole numbers. Let me see, where did my whole numbers go? There they are, the whole numbers, and they have a symbol. It's a W with a couple extra bars. Oh, the naturals have that symbol there, the N with the extra bar. So the W looks like that. The whole numbers, and they're just like the natural numbers, except they begin with 0. You may not realize this, but 0 wasn't always known, the value of nothing. All right, it's a very important number. It was actually discovered by the Mayans, or first considered by the Mayans. I guess it wasn't actually discovered, but they're the first people to start working with 0. Some brilliant math people, the Romans beforehand, the Greeks, they didn't know about 0, and their mathematics suffered for it. Okay, they didn't understand about assigning a value to nothing. So again, the whole numbers are just like the natural numbers. No fractions, no decimals. The only difference is that the whole numbers include 0, where the natural numbers do not. Okay, so every natural number is a whole number, but not all whole numbers are natural. See, it doesn't go both ways because 0 is not natural. Okay, the next number system are called the integers. And they have a special symbol. It's a Z, and they reserve I for something we're going to see in a couple of minutes here. Z, probably because integers has a Z sound in it. Okay, that's probably why they use a Z. I don't actually know, but that's my guess. Anyway, the integers are just like the whole numbers and the naturals. They include 0, 1, 2, 3, on forever. There's no fractions, no decimals, but they also include the numbers before 0. Here, let me do this. Hold on one second. I'm going to put this 0 in green because it's different than the natural numbers. So let me put the 0 in green. Okay. Now, the integers include the 0, 1, 2, 3 on forever, but they also include -1, -2, and -3 on forever in the negative direction. Okay? Now, it's interesting to note the natural numbers begin with 1, the whole numbers begin with 0. The integers have no beginning. No, there is no smallest integer. Okay, no matter what integer you name, -1055, I can name a smaller one, -1056. And then you can name a smaller one, -1057, etc., etc., etc. They get smaller and smaller and smaller. No beginning, no end. One way to help you remember the integers is to think about a number line without fractions or decimals. Okay, it's kind of a good model. Again, we're not considering the numbers in between, only the whole numbers and their negatives. Okay, so that's your integers. Now, we also have the rational numbers. And the rational numbers include all of the integers. So they include -3, oops, hold on a second. They include -3, -2, -1, 0, right? And then 1, 2, 3. But they also include all fractions of integers. So if you can take a fraction like 1/2, that's using 1 and 2, both integers. So it includes all fractions of integers. So like 1/2, -5/7. Okay. Let me see here. 3 and 8/17. Okay. And they also include decimals that do one of two things. Decimals that either end, like 3.14, or 2.5, or -7.235. All those decimals end. Or decimals that repeat. Repeating decimals, like 1 6/10 repeating, -5.1423, and the 3 repeats. Okay, so they include all the previous numbers, the integers and fractions that are written with integers, decimals that end or repeat. Now, there's a group that's a little bit separate, and they're called the irrationals. The irrationals are special numbers. They have a symbol I. This is why we don't use I for integers. And the irrationals only include decimals that never end and never repeat. Okay, very famous one that you all know, pi. There's the symbol for pi. Pi is not 3.14. Pi is 3.1415, and it goes on forever without repeating. Now, interestingly, the square root of 2 is irrational. The square root of 3 is irrational. The square root of 5 is irrational. The square root of 6 is irrational. The square root of 7 is irrational. The square root of 8 is irrational. The square root of 10 is irrational. Notice I'm skipping some numbers. I don't have the square root of 4. It's not irrational. Why? Because I can take the square root. Square root of 4 is 2 or negative 2. I didn't put the square root of 9 in because it's a perfect square. Okay? Square root of 9 is a rational number. Didn't put the square root of 1 in. It's a rational number. But if the number underneath the rad symbol is not a perfect square, then it's going to be an irrational number. Okay, so together they all make up the real numbers. Now I'm going to give you a little Venn diagram here, and I'm going to start with an oval like this. And this is going to, oh, I guess I should do that in black, sorry. I'm going to do it in black. And that'll be for the natural numbers. And the natural numbers are 1, 2, 3, etc. Okay? And then, what were my whole numbers? My whole numbers were in green. Okay, so then my whole numbers are another circle here. And they have this W symbol. And they're just like the natural numbers, except they include 0, 1, 2, 3. Okay? Now, it's interesting. If I have a natural number like 1, am I also inside the whole circle? Yeah, I am. This 1 is inside the black circle, isn't it? But isn't the green circle around it? So you see, 1 is both a natural number and a whole number because it's in both circles. The 0, on the other hand, is not inside the natural circle. It's only in the green circle. Okay, and then after that we talked about the integers. And the integers, remember, include -3, -2, -1, 0, 1, 2, 3, on forever in both directions. Now check this out again. This 1. Is 1 a natural number? Sure is. Is 1 a whole number? Yeah. Is 1 an integer? Yes. If I'm in the black circle, name a number in the black circle. How about 35? Okay, is 35 natural? You bet. 35 is a natural number. Yes, it is. But it's also a whole number because it's inside the green circle. Right? And it's inside the blue circle. Eventually, if I keep counting, I'll get to 35. So you see 35 is a natural number, a whole number, also an integer. Okay, now after that, we talked about the rational numbers. And the rational numbers have their own circle. And they include all the previous numbers, but they also include fractions of integers, meaning you have to use 2 integers to make the fraction, or decimals that did 2 things. They either ended or repeat. And so the examples are like -1/4. I use a -1 divided by +4 and I get a rational number. I could use a decimal that ends 3 72/100. I could do a decimal that repeats 0.6 repeating. Okay, 0.142857 repeating. Those are all rational numbers. Okay, 55, 56 is a rational number. Now, the irrationals, which I think I did in Poiple, just love to say it that way, have their own oval over here by themselves because they don't fit. See, rational numbers have no fractions, irrational numbers, no fractions of integers, and they only include decimals that don't end or repeat. Okay, the most famous example again is pi. I'm going to kind of extend that so we can get some examples in here. All right. And so they include pi. They include decimals that go on forever without repeating. Okay. They include square roots of non-perfect squares. So there's some examples of integers. Now all together, all of these numbers make up, what color did I use for real? Looks like I just did black. Oh, I guess I should have done natural and red, but that's okay. All together, these subsets make up what we call the real numbers. Okay? So we're going to get some practice with this tomorrow. What I'm going to do is I might ask you to name a number that is rational but not a whole number. All right? Or name a number that is a whole number that is also rational, etc. Name all of the number systems that 5/7 is a member of. Things like that. And I'll show you how that works. Make sure you have this diagram in your notes. Okay? Make sure that you understand many of the examples, and we'll get some practice with it. All right, that's the lesson for today. Mr. Lawrence signing off. Have a good night, everybody.